My presentation is about matrices in computer graphics. But first, a disclaimer.
Because of the time constraint of only 5 minutes, I cannot go through some of the complicated concepts. However, since it is a video, the learner can always pause, rewatch, and think in his or her own tempo.
In this presentation, I will talk about the basic transformations on a triangle. These are scaling, rotating, and translating the shape. On a 2D plane, every shape can be represented as a set of triangles. So it will make sense if we think about one triangle at a time. And by modifying a triangle, we know how to modify the entire shape. Here we have an arbitrary triangle on a 2D plane. It can be modified by using matrices multiplication. Let's have a quick look at matrices multiplication. We can modify a shape by modifying its plane. This kind of transformation can be described by showing where the unit vectors will land. In this example, I want to stretch the I hat vector by 2 and the j hat by 1/2, and I put new values here in this matrix. The beauty of matrices multiplication is that we can apply this transformation on one point, on multiple points at the same time. It's not convenient though to put all points in the same multiplication because it will take a lot of time. What video cards do is to apply this transformation on small sets of points, so to make this process parallel and very quick. By doing the actual multiplication, we get the new values. And by knowing where the vertices are, we can draw the lines between them. So this is how you stretch or scale a shape. Now let's go back to the original example and let's try to rotate it a bit. In this example, I want to rotate it by minus 30 degrees. By knowing how to determine the new positions of the unit vectors, we can get another transformation matrix. For rotation, we can use trigonometrical functions. So we know that the cos will show us the x position and the sine will show us y position of the endpoint of the vector. And to find for the j hat, we have to add 90 degrees. And by applying some trigonometrical functions and equivalences, we get these new values. By multiplying this transformation matrix with the set of vertices, we indeed have the new values of the vertices, which appears to be negative 30 degrees rotated. In the real world, we usually want to do more than one transformation at a time. So for example, we want to scale this triangle and after that to rotate it. Sure, we can do one by one, but we know that matrices multiplication can be associative. So it means we can group all previous transformations in only one matrix and applying this matrix on all vertices. This will save a lot of time. I have to make clear that matrices multiplication is not commutative. That means if we change the order of the transformations, we get a completely new shape. So now I want to do two transformations, the same exact transformations as in previous example, but now I will do the rotation first and the scaling after. As you see, we ended up with two completely different triangles. We now have seen that rotation and scaling work well together. But for example, we want to translate this triangle on x and y axis. To do that, we have to add some values to the vertices. In theory, we could do that and it will work fine, but this means a lot of time wasted on adding and multiplying. Instead, we want only to multiply or only to add, but multiplying is more realistic. So mathematicians worked out a way to do that. On the right column, we add the amount on x-axis on the first line and the amount of y-axis on the second line. And the third line will be just 2 zeros and 1 to make it work. We also need to add a new row of 1s on the matrix of points. It seems like we add a new dimension, and if you picture that in the 3D space, it will make sense. But the most interesting fact is that for a 3D transformation, you have to add the fourth dimension, which is hard to picture it in mind, but works the same way. So this was my presentation about computer graphics and matrices and how they're related to each other. And I want to close with an animation that shows the same process in action.